Hello everybody, welcome to the day 4 lesson for the MBF3C correspondence course. Yesterday we looked at how we collect stats and we started to look at how we analyze stats. When we were looking at analyzing stats, we focused mostly on the bias that can be produced by the stats. So how does the responses to the questions kind of lean one way or the other? Today we're going to look at some numerical analysis of the stats. So there's two different types of numerical analysis that we're going to look at, or what we call quantitative data. So how do we measure these stats in a way that talks about the numbers? Those two ways are measures of central tendency, which we're going to start with, and then later on we're going to talk about what we call measures of spread. So when we collect data, we usually want to know what values lie in the middle of the data set. So these values that lie in the middle, or the ways that we look at what values lie in the middle, we call the measures of central tendency. Before we look at the three different measures of central tendency, we're going to look at one that we should all be familiar with, which is average. So the example for this, Ms. LaRock wanted to determine the average for his grade 11 college math class. The grades can be seen below. We want to determine what the class average is. Now when we're looking for the average is equal to the sum divided by the number of numbers. So the sum, what that means is all of the numbers added together, and then again we're dividing it by how many numbers we actually have. So in this case, again, our sum is equal to 68 plus 75 plus 54 plus ... So we're adding up all the numbers until we add up those last two, 60 and 70. We'll do this quickly. So 68 plus 75 plus 54 plus 91 plus 83, and so on. And so adding up all the numbers, we get our sum is equal to 1,724. If we count how many we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19, 20, 1, 2, 3, 4. There are 25 numbers. So since we know the sum and we know that there are 25 numbers, finding the average is fairly easy. Again, the average is equal to the sum, which is 1,724, divided by how many numbers there are, which is 25. And if we do that division, we end up with an average of 68.96. Now, the three measures of central tendency are called mean, median, and mode. The mean is actually what we just found. The mean is also called the average. So mean or average, they're used interchangeably. Again, they're found, we determine the sum of all the data points, we add them all together, and then we divide by how many there are. The median is found by listing all the data points in order, and that's very important and something that a lot of students forget to do. You have to list the data points from smallest to biggest, and then finding what the very middle value is. If there's an even number of data points, so for an even number of data points, we take the two middle values and find the mean of those numbers. Basically what that means is we add the two middle values and divide by 2. The mode refers to the most commonly occurring data point. A lot of times it's one of the numbers in the middle, but it's not always. Sometimes it is. It could be one of the higher numbers, it could be lower the numbers. It really could be any of the numbers. So the mode, we call it a measure of central tendency, but it's not always a number right in the middle like the average and the median. The mean and the median usually are. So the next example wants us to determine the median and the mode. We've already found the average or the mean of the data set above. Now we want to find the median or the mode. And the mode. Again, to determine the median, the first step is to write out the numbers in order. So to find the median first, we're going to go up to the data and we're going to find what the smallest number is. Now, when I put them in order, I like to underline the data. I underline them so I can still see what the number is, but to show that I've used that number. So if I scroll up and I look for the smallest one, the smallest data that we have, it looks like is 42. And then I'm going to look at a couple others. So it goes 42. Looks like we have two 53s after that. So I'm going to write out 42, 53, 53. Again, go up and keep going. So we have a 54 here, 55, and so on. So I'm going to pause the video, fill the rest of this in, and then I will go from there. Alright, so I filled them in from, wrote in the numbers from smallest to biggest. If we look up, I've underlined every number so I know that I've used every single one. I've double checked, I've counted the numbers, and we have 25 of them. So now I'm going to find the median. Now to find the median, there's a couple ways we can do it. The first way is to just say, start canceling out numbers from each side. So again, I underline them so I can still see the numbers. And underline 5 from both the smaller side and the bigger side. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We're not even close to the middle, so I'm going to do another 5 from each. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to do 1 from each side, another from each side, and so that number right in the middle is my median. So for me, my median is 70. My mode is the number that appears the most. When they're in order, it's fairly easy. I have 3 68s. I have 2 53s, I have 2 70s and 2 71s, but I don't have any other number where there are 3 of them, so my mode is 68, and I have 3 of them. So again, with this example, the mode was 68, which is close to the median of 70, and also almost the same as the average. That's not always going to be the case with the mode. You may get some higher modes, you may get some lower modes. Even though the mode could be the smallest number or the biggest number, we still call it a measure of central tendency. It is also possible to get more than one mode. It's whatever number appears the most. So if you have 2 different numbers that appear 3 times and that's the most, then both of those numbers would be the mode. So we're going to try this again. The number of 3-syllable words found on 14 random pages in Harry Potter books are shown. We want to determine each measure of central tendency for the data set. Again, we'll start with the mean, and the mean is the same as the average. So that's the sum divided by, there are 14 pages, so this will be sum divided by 14. The sum is adding them all together. So if we do that, and again, I'm going to pause the video, do that. So adding all the numbers together gives us 966. Again, to find the average, you divide by how many there are, which is 14, and that gives us 69. So the average number of 3-syllable words is 69. If we want to find the median, again, for the median we have to arrange them in order. So the smallest one is 14, next looks like 40, and go from there. 52, 56, 63, 67, 68, 71, 76, 71, 76, 83, 89, 94, 94, oops, 99. Now again, you should subtract 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14. Now, I showed you above, one way to find the median is to cancel out numbers from either side. The other one is to find out how many numbers there are on either side. And to find out how many numbers there are, you take how many numbers you have, divide that by 2, which is 7. And what that means is there are 7 numbers on either side of the median. So essentially what we should be able to do is cancel out 7 numbers on either side, and that will bring us to the median. So 1, 2, 3, 4, 7, 1, 2, 3, 4, 5, 6, 7. Now that means the median is right between 68 and 71. So to find the median, we add those together, 68 plus 71, and divide by 2. 68 plus 71 gives us 139, divided by 2 gives us 69 and a half. The mode, if we look at these, the mode is right here. I'll do that actually in green. So the mode is here. There are 2 94s. So our mode is 94. Again, there are 2 of them. So this is an example of what I was talking about. The mode may be one of the bigger numbers. It doesn't necessarily have to be in the middle. We still call it a measure of central tendency, even though it's one of the bigger numbers. Which measure of central tendency best describes the data? Again, this is really, you could pick any of the 3 as long as you have a good explanation for why. So you could say, for example, mode, even though we only have 14 pages, we got 2 94s. So you could say that the mode is the most common and what you would most likely see. You could say because the mean is the average, since the mean is the average, again what that means is when you add all the pages up and divide by how many, that's what you get. It's usually fairly safe to assume that for any, if you did this 25 times, the average would still be similar. So the mean kind of tells you what most of the pages would be around. Median in this case just kind of tells you the middle number. So you could actually have a bunch of numbers above that median, a bunch of numbers below. It really just tells you which one is in the middle. Now it's close to the average, so you could argue the median as well. Now sometimes your numbers are going to be in grouped data, and you want to determine the mean, the median, and the mode. The mode is fairly easy to see. The way this group data works, it tells you what the prize value, so this is a charity fundraiser, charity auction for example, and it tells you how many of them there are. So with the mode, you're just looking at which one has, of these 4, have the most number of prizes, and that for us would be 100. There are $2,500 prizes. Now, to find the average, we need to add up every single prize that's possible. In that case, we have to find what we call the cumulative frequency. The cumulative frequency is the total amount for that prize value. So, what x times f means, that dot is multiply. So x dot f means 5,000 times 1, and the cumulative frequency for the $5,000 prizes is $5,000. X for the is $1,000 prizes. There are 4 of them, so the cumulative frequency is for the $1,000 prizes is 4,000. The next one, you have $500 prizes. There's 10 of them. 500 times 10 is 5,000. Finally, the $100 prizes, there are 25 of them, and that gives us $2,500 or 2,500. Now, once you find the cumulative frequency, the sum is adding that all together. So we have 5,000, 9,000, 14,000, 16,500. And in total, if we add up how many of each prizes we have 1, 5, 15, 40 prizes in total. So for this one, our average or mean would be the total cash value of all the prizes, which is 16,500, divided by the total number of prizes we have, which is 40, or $412.50. Finally, the median is a little bit trickier. For the median, I'm going to write out that table that we have again. So we have $5,000 prizes, 1,000, 500, and 100. And I'm going to write out how many prizes we actually have. So we have 1 5,000, 4 1,000s, 10 500s, and 25 1,000s. Now, to find the median, I'm going to start canceling out prizes on either side. So I'm going to cancel out the highest prize, and I'm going to cancel out the same number of the lowest prize. So we have one $5,000 prize. I'm going to cancel out one of those 25 at the bottom, which leaves me with 24. We have 4 $1,000 prizes, leaves us with 0. I'm going to cancel out 4 more of those lower ones, which gives me 20. We have 10 $500 prizes, cancel out 10 of the lower ones, which leaves me with 10. What that tells me is there are 10 $100 prizes in the middle. So our median is equal to 100. That should be 100 there, not 1,000. Now, the reason we did it that way, you can write out the numbers from smallest to biggest, but if you do that, it would be 100, 100, 100, and you'd be doing this 25 times, and then you'd have to write out the 500 10 times, and so on, and that is a lot more work than you have to do. So again, what we did here, we canceled out however many of those high prizes we have, we canceled out the same number of the low prizes. So we canceled one $5,000 with one of the 100s, 4 1,000s with 4 more of the hundreds, and so on. And whatever prize number, whatever value you end up with, still having a number in, that is your median. So we still ended up with 10 $100 prizes once we canceled out all the high ones and the low ones, which means that our median is $100. Now, those are the measures of central tendency. Again, those kind of show you the middle values and help us see what that middle value is for different kinds of data. Now we're going to look at the measures of spread. It helps us to know what the middle value is, but it also helps us to know how spread out the data is. So, for example, are most of those values around that middle? Is the data fairly well spread out? That might tell you, for example, if you have a lot of students around like a 70% in your class, then that's what you like to see as a teacher. A lot of those students kind of in the average range. If the data's really spread out, or you have a lot of students with high marks and a lot of students with low marks, but not a lot in the middle, it might tell you that your material's too hard and only the people, the really, really smart people are getting it, everyone else is struggling. So the first and the simplest measure of spread that we're going to look at is range. Range is the distance between your highest point and your lowest point. So if Aisha has 11 monthly cell phone expenses and they're given to us in dollars, again, the range for the data is range equals highest minus lowest. So the range for our data, our highest value, if we look at these numbers, would be 90. Our lowest value, if we look at the numbers, is 61, and so the range for our data is 29. So there's a $29 difference between her lowest bill and her highest one. The mean, or again, the mean stands for average. We add them all up and divide by, we know there's 11 numbers, so divide by 11. That's equal to the sum divided by 11. The sum for the data is 833. Again, there are 11 numbers, which means that our average is 833 divided by 11, or 75.72. So her average cell phone bill would be 75.72. Now, there are three other measures of spread that we're going to look at. The first is called the deviation. The deviation is the difference between any individual value and the mean. So what's the difference between, say, the highest one, 88, and your average, which for us would be 90, minus that 75.72. The variance, it's a mouthful. You don't really need to understand what it is as long as you can find it, but it's the mean of the squares. So we take the difference between each point, we square that difference to make all the numbers positive, add them up, and then divide by how many we have. And the standard deviation is we take the variance and we square root it. The standard deviation is the most common measure of spread that you're going to see. Basically, the bigger the standard deviation, the more the data is spread out. The standard deviation tells you what number most of those data points are away from the middle. So say your standard deviation was 2. What that means is that most of your data points are 2 away from whatever your average is. Now, to find these standard deviation, it's really good to set up the information in a chart like this. On the first column, you actually write down all of the monthly expenses. So again, we have those numbers there: 83, 77, 61, 88. And so again, we're just filling all of these in. Once we've filled in each number, we're going to find that deviation. Again, the deviation is the difference between the actual expense and the average. Our average was 75.72. X with a line across is another way of showing average. So what we're doing is we're doing 83 minus our average, 75.7. I'm just going to round it to 75.7. And we're finding out what that is. So 83 minus 75.7 gives us 7.3. 77 minus 75.7 is 1.3, and so on. Now you'll notice if your number is below your average, then that deviation is negative. If that number is above the average, that deviation is positive. So we're just working through this. So I've found all the deviations, I found the differences. Each point is away from the average. The next part, to find the variance and the standard deviation, I take those deviations, those differences, and I square it. So I have 7.3 squared, 1.3 squared, negative 14.7 squared, and so on. All of these should end up being positive. The reason we square it is to make sure that each number is positive. You get 53.29 for the first one. 1.3 squared is 1.69. We have 14.7 squared, 216.09. And again, if we continue that, so I've taken each of those deviations, I've squared them. What we need now is the sum, which is adding up all of those differences squared, and doing that we get 1001.99. Now to find the variance, we take that sum, we divide by how many numbers we have, which for us is 11. So that's 1001.99 divided by 11 gives us 91.09. And then we define the standard deviation. We take that variance and we square root it. So the square root of 91.09, which gives us about 9.5. Now again, what that standard deviation, so we got 9.5. What that means is that most of the numbers are within 9.5 of the average. So to see what range that is, you can take your average, 75.7, and add 9.5, and then take your average and subtract 9.5, and we get 75.7 plus 9.5 gives us 85.2. 75.7 minus 9.5 gives us 66.2. So we could say most of our numbers are between 66.2 and 85.2, and if you were to look at your numbers, you would see that that is the case. Now, that's one standard deviation away. If you go two standard deviations away, so for us that'd be 9.5 times 2, or 19, you would basically most of the numbers are within one standard deviation, or for us 9.5 away, almost all of the numbers are within 2 or 19, and so on. Essentially 100% of the numbers are within 3, but that's what the standard deviation is. It basically gives you a numerical value where you can say with confidence most of the numbers are within this this much away from the average. The last measure of spread that we're going to look at is quartiles. Above we learn the concept of the median. So the median is the middle value, or it's the value that divides the data set in half. We can also divide each of those halves in half, or essentially we're dividing the data set into quarters. And the numbers that do this, the numbers that divide your data into quarters, are what we call quartiles. Now again, in order to find the quartiles in the median, we need to arrange the data from smallest to biggest. So we have the following list of daily high temperatures in February. We want to determine the mean, the median, and the mode. Again, we'll start with the mean, which is the sum divided by the number that we have. Since it's February, there would be 28 numbers. If we want to find the sum, so our sum for this, if we add all those numbers together, is negative 49. Again, realizing that if you're adding a negative number, it's really like subtracting, so you can have a negative sum. Our average, we're taking that sum, and we are dividing that negative 49 by how many numbers we have, or 28, which gives us an average temperature of negative 1.75 for the month of February. For the median, we need to write those numbers from biggest to smallest, so I'm going to do that now. So I've written the numbers from smallest to biggest. Again, we know there are 28 numbers. So if there are 28 numbers, 28 divided by 2 is 14. So there are 14 numbers on either half, which means if we're trying to find the median, you can cancel out 14 numbers, so 5, 9, 10, 11, 12, 13, 14, and our median should be right about there. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now because the median's in between the two negative 2's, because of the same number, we don't need to do this, but again, when you have two numbers in the middle, you add them up, divide by 2, gives us -4/2, or a median of -2. When those numbers are the same, you don't really need to do that step. When the two numbers in the middle are the same, those are the median. That whatever that number is the median. Now the mode, again, we're looking for which one appears the most often. We can see there are 4 -3's. There are also 4 2's. So this is an example where we have two modes. Our mode would be -3 and 2. And again, there are 4 of each. Now, what we're going to do is divide the data into 2 halves and determine the median of each half. So the first half, we know we have 14 numbers on either half. If we take those 14 numbers and divide that by 2, we get 7. So what that means is there are 7 numbers in each quarter. So basically we can go 1, 2, 3, 4, 6, 7. Again, our median is here, so our half goes 1, 2, 3, 4, 6, 7. Here are the two numbers in the middle. Right in between it, if we add it up, we call this Q1. That basically is saying that that's the end of the first quarter. A Q1, we add those two numbers up, -5 plus -4 and divided by 2, which gives us -4.5. If we do the same thing for the second half, so 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. These two numbers are in the middle. That we call Q3. That's essentially the end of the third quarter. The median you may also see as Q2. So whatever numbers after the Q, that's saying it's the end of that quarter. Q1 is the end of the first quarter. Q2 is the end of the second quarter, also called median. Q3 is the end of the third quarter, and then Q4 would be the biggest number. Now when you look at this, in between each line you should always have the same amount of numbers. We have 1, 2, 3, 4, 6, 7 numbers up to that first one. 1, 2, 3, 4, 5, 6, 7 numbers up to the second line, and then 7 after that, and 7 after Q3. Now again, because there are two numbers in the middle of between the third quarter and the fourth quarter, we have to add those up, divided by 2, gives us 3/2, or 1.5. The inner quartile range tells us the distance between that Q1 value and the Q3 value. So for us, our interquartile range is Q3 minus Q1, or 1.5 minus -4.5. When you're subtracting the negative, it's the same as adding, or 6. Now, what are some benefits of using the IQR compared with range? The range only tells us, the difference between highest and lowest. Because the interquartile range is the difference between the middle of your first half and the middle of your second half, the interquartile range really tells you how spread out the data is around the middle. If you have a small interquartile range, the data is very close to the middle, whereas if you have a bigger interquartile range, the data is more spread out around the middle. So it tells you how spread data is around the median. Now there's one more type of plot we can make with this. Once we know the max, the min, the Q1, the Q2, and the Q3. Again, Q2 is also called the median, and that's called a box and whisker plot. Essentially, the way this box and whisker plot works, the lowest, the start of that line that we see is our min, the end of the line that we see is our max, the first line here is our Q1 value, here is our Q2 or our median value, the end of that box is our Q3 value. So each of those different segments, the first line, the first box, the second box, and the second line, those are each a quarter of the data. So a box and whisker plot does a really good job of showing you how spread out each quarter is. Again, the following is a list of shoe sizes of each of the members of the class. We want to create a box and whisker plot for this data. So in order to create a box and whisker plot for data, you need to know the highest number, so your max, your min, your Q1, your median, and your Q3. There are 5 points of data that you need to find. Our max for this data, if we look at this, the biggest shoe size is 13. Our min, the smallest shoe size, is 6. To find the median, the Q1, and the Q3, you need to order the data from smallest to biggest. Alright, so once we've written the numbers out from smallest to biggest, again you should always double check. There are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 5 numbers. We have 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5 numbers. Everything checks out. We're going to count the data. Now, when you have an odd number, so 25 divided by 2 is 12 and a half, what that tells you is there should be 12 numbers on either half. So when we find the median and we cancel out numbers, we should cancel out 12 on either side. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So here is our median. I'm going to put a line through that number to show that it's our median. So our median is equal to 9. Again, to make a box and whisker, I need to find my Q1. The Q1 is the middle of the first half. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have these two numbers in the middle, and my Q1 is right between them. So Q1 is 8 plus 8 over 2. Again, because they're both in 8, we don't really have to do this. Our Q1 is equal to 8. Our Q3 is the middle of the second half. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There. And the Q3 is in between those two middle values. So 10 plus 11 over 2, or 10 and a half. Once we know our max, our min, our median, our Q1, and our Q3, we can draw our box and whisker plot. So to draw our box and whisker plot, we're going to start with the number line. On the number line, we're going to put our numbers, so 5, 6, 7, all the way up to at least 13. Again, with the box and whisker plot, you put a point for your smallest number, which is 6. You put a point at your max, which is 13. We draw a line for our median, a line for our Q1, and a line for our Q3, which is 10 and a half. We create a box around those lines, and then we draw a line from our min to the box and our max to the box. So again, here's our min value, our Q1, our median, our Q3, and our max. So our min value is 6. Our Q1 is 8 plus 8 over 2. Again, because they're both in 8, we don't really have to do this. Our Q1 is 10 and a half. Once we know our max, our min, our median, our Q1, and our max to the box. So again, here's our min value, our Q1, our median, our Q3, and our max value, and you can see that again, a box and whisker plot does a really good job of showing you how spread out your information is, and more specifically how spread out each quarter is. Now, just to make sure, again, you can count how many numbers do we have in between these lines. When you have one like this where the line goes through it, you don't count that. So with 1, 2, 3, 4, 5, 6 before the Q1, 1, 2, 3, 4, 5, 6 between the Q1 and the median, 1, 2, 3, 4, 5, 6 before the Q3, and then 6 after the Q3. Everything checks out. Again, homework's been posted throughout. Now with this unit this lesson, there is an assignment that you need to complete as well, where you will need to draw a box and whisker plot. So make sure you check both the quiz folder and the assignment folder for the assessments for this unit. Good luck.